Welcome to our next chapter in the GitHub Automations course. My name is Candace Savanen. I'm a data scientist for Fred Hutchinson Cancer Center, and here we're going to talk about why should we use automation anyway. This is our licensing information for this course. All right, so in this chapter, we're going to demonstrate how to understand how automation aids in reproducibility and efficiency. We're going to try to recognize that science and quality code bases is a community effort. We're going to try to understand that the concept of continuous integration and continuous deployment is important and can be applied to science. And we're going to try to apply the concept of CI/CD, or continuous integration, continuous deployment, to the scientific problem. In our previous courses in this specialization, you will hear us talk about reproducibility. And reproducibility is the idea that if we hand our code and our analyses to another person, then they should be able to rerun that code with that same analysis. But before we can even get to reproducibility, we can think of this as a pyramid of how science works. And on the bottom of that pyramid, we have repeatability. And that is where us, the same researcher who made the thing, the analysis, or what have you, and the same data, we repeat the same thing we did. Because if something is not repeatable, it cannot be reproducible. So repeatability is the first step. Can we ourselves, with our same code, same data, get the same result? And actually, this is surprisingly a very time-lengthy step. Okay, this is not a trivial part of the process. But after we feel pretty reliable that I can get the same results and that I can day after and day in, day out get the same results, then we're going to hand it to our collaborator who's going to see if they can also get our same results using the same code and same data. Now, if we document everything really well and we make sure that every step is scripted and all the other steps and nice tools and things that we talked about in our previous specializations, then things will be reproducible. And one other thing that we can do to help things be is automation. We'll talk about that in a second. But then why that is so important is that at the very top of this pyramid, there's replicability. And replicability is what allows science to start to inch forward with progress about a particular concept. So replicability means then that it might be a new researcher, but there's definitely new data. We're going to try to take what we've learned in this instance, and we're going to collect new data on it and see if the concepts now can be extrapolated into a new finding in a new direction, and we can continue to build that snowball of science knowledge. This is also important because it saves people time. Reproducible work is not only just important for science to move forward, which is enough of a reason in itself, but it's also important because other folks are going to be using our methods potentially, right? Some of the things that we create, whether they be used by us in the future or they're going to be used by our collaborators, they will save everybody a lot of time if they are made more robustly. And you'll notice that in this scenario, we have a researcher, and this researcher is, has methods that are going to be used by 7 different folks. And there, you still see there is one person who's having an error and the other 6 are doing it great. So it doesn't mean that everything will be perfect, but we're just going to continue to strive for things to be more reproducible. So that way, again, it's scalable throughout the research community. So that is why I say that much like wine and cheese or a nice grape juice and cheese, automation and reproducibility are a great pairing. They go really well together. They promote each other, and it's a great skill set. And that's why I'm glad you're in this course. Because ultimately, we want to be thinking smarter, not harder. Right? We want to use automation to help us save time and also help us do things in a way that are more efficient and more thorough. So it's just a great tool set because this is not an infrequent example of where we might need to reproduce our results, for example. Let's say we submitted a manuscript, reviewer 2 asks, hey, can you please rerun the analysis in the paper, but with these altered parameters? And we might say to ourselves, it's just 2 parameters. How hard could this be? Let's just rerun it. It shouldn't be that hard. But frequently it is. It is hard, frequently. And when we try to rerun it, depending on how long ago we built this, what else has happened in between, how we built this, we might find ourselves in a big side quest of figuring out and troubleshooting this analysis. Okay. A lot of people have been here. There's no shame in this happening to you in a scientific quest. However, the point of reproducibility skill sets is to hopefully also avoid this kind of headache, because this also makes us kind of question the results we got in the first place if we can't rerun them reliably. So automation then can help by being a part of our whole development process. Automation can help by ensuring that when we make any change to the code, we're going to rerun it. You can imagine I could ask a collaborator, a fellow colleague, to rerun my code every single time I changed it. But that wouldn't really be a great use of their time, because they're also probably busy too and have a lot of things they're doing for their projects. So instead, what we can do is use something like GitHub Actions to, every time we change our code, we're going to have GitHub Actions rerun it. And that right there is going to help us identify problems with our code a lot earlier than we would otherwise. We could think of an analogy like this. Where let's say we're a construction manager and we're building a large apartment building. Would you, even if you have no knowledge of construction, would you make sure that your construction plans meet certain safety standards and tests and engineering standards as you build it along the way, as you continuously develop it and continuously integrate new things into the apartment building? Would you want to make sure that as you deploy this new apartment building, it is meeting these standards? Or the other alternative is you could just build the whole thing, don't check anything as you're building it, and then like if something breaks, we'll just build a new apartment building and demo this. Obviously, I'm being a bit facetious here. The second option is really not that practical, but sometimes this is a little bit of a trap we get into for ourselves when we're doing scientific software development. So really the whole point of continuous integration, continuous deployment is that we're going to try to be pragmatic about our future work. We understand that we are imperfect humans in imperfect working conditions, and that means we're going to make imperfect code, but how can we kind of accommodate for this? How does CI/CD, or continuous integration, continuous deployment, help with that? So let's talk about that. So problems without using these skill sets, they might arise without us knowing it. We might have bugs being introduced at a certain rate, and then when we finally do recognize that we have bugs, we might have a whole bunch of bugs mixed in there that we have to parse out and figure out how these came about and how do we fix them. That'll be a lot trickier than if we used a continuous integration, continuous deployment type scenario in which it'll help us identify bugs every time we kind of see them arise. And so that's part of the motivation. This also applies not just to bugs, but it could apply to changes in results. As we know, reproducible results not only mean that the code can be rerun, but it means when we rerun the code, we're going to have the same results. So if we have a slight difference, this kind of setup can help alert us to that fact before we get there. So then continuous integration, continuous deployment, which is a mouthful, is a software skill. And we're talking about now using it in the context of science. So in a more traditional software setting, and you might make scientific software yourself that other people are using in a more traditional sense. And that might look like something like this, where we have version control and we're developing, we're building things. We might be testing and staging those changes and developments. And we're going to have something automatically test if it's good or not. Like, can we actually do the things that we need to do? And then after all that, we're going to try to deploy those results, deploy that software. And in the context of more of a traditional analysis pipeline, not so much the package, but in a context where we're using scientific software, we might see this instead as being like building the analysis is our product we're working on. And instead, we're going to check that the changes that we added to the analysis, can we still rerun the analysis? And then we might think of instead as our deployment as being making a publication. That might be an output of where we're putting that, among other things. So this is, again, how we can take this concept from software development, but apply it to data analysis. So hopefully this is motivating you to want to use automation techniques for your software in science. And from here, we're going to learn more about how to actually do it and get our hands a little dirty with some GitHub Actions.